Hey team, I'm Maddie. Welcome to Science Side Up, and today we're going to answer some science questions from 5th graders. So 2 things. One, a wonderful cold front moved through last night, so it's no longer 120 degrees in my garage, and I can film in here with my lighting and my mic, and hopefully this looks and sounds better than my last few videos. Sorry about that, team. Second is a couple weeks ago, I had so much fun doing a Zoom call with a 5th grade class here in Oklahoma. They were all kids who are studying remotely for this semester, and we just got to chat about what it means to be a scientist, what different scientists do, and they had some really great questions for me. I thought it would be fun to share some of those questions and my answers with you guys. Our first question is, how likely is it for the Earth to get hit by an asteroid? So I assumed that this young man was asking about the probability of like a cataclysmic extinction level event like what killed the dinosaurs. So that's the answer that I gave. And so the probability of the Earth being hit by a giant asteroid that's going to, kill all life on Earth is actually really low. And there's a couple reasons for that. One, asteroid impacts are much less common now than they were when the solar system was younger. That's not to say that large asteroid impacts aren't possible now, but they were much more common about 4.2 billion years ago. Solar system is 4.5 and change billion years old, and around 4.2 billion years ago, there was something that was called the Late Heavy Bombardment. And this was sort of the last-ditch effort of all of the rocks and dust and ice that hadn't made it into the planets that we know and love, were careening around our solar system, wreaking havoc, smashing into things. And in fact, if you look at, say, the surface of our moon or Mercury or Mars, where there's so many crater impacts that are just visible, most of those are from the Late Heavy Bombardment. So most of those are 4.2 billion years old. But after that time, all that leftover bits that didn't make it into a planet kind of got pushed out onto the outer edges of our solar system into what we now call the Kuiper Belt. And we'll touch on the Kuiper Belt a little bit more when we get to another one of the questions. So the second reason that an asteroid impact on Earth, like a big one, isn't all that common is that our moon does a really good job of catching asteroids for us. So it's nice. We have this like protector moon hanging out with us. Now, if you're still worried about a extinction level asteroid impact event, there is a branch of NASA that keeps track of asteroids for us. So kind of, I guess, know that we've got people on that. Now, this led to a follow-up question from the same person. So this is our second science question from 5th graders, which is, if you think you found a meteorite, what should you do with it? And so this young man told me a story about how his mom found a piece of rock that had like fallen out of the sky. And I didn't know at the time exactly what one should do if you thought you'd found a meteorite. But after the fact, I did a little Googling, I did a little digging, and I found a great meteorite research lab at University of Nevada, Las Vegas, where you can send a sample if you think you have found a meteorite. So I'll put that link in the description below. Third question was, how do people predict the weather? And I thought that was such a great question. And so the answer that I gave to the class, so I'm going to kind of answer this to a 5th grade level. Scientists and technicians all over the country and all over the world who use different instruments like thermometers and anemometers and barometers to measure things like wind speed and temperature and pressure, air pressure. And all of those people report all those numbers to, for us here in the US, the National Weather Service. Then the National Weather Service takes all that data and dumps it into a supercomputer that has a numerical weather model, so a mathematical representation of what the weather does. And then they run that forward in time and they tell you what's going to happen next. And that data is reported to them. It depends on the source, but usually you get new data like every 6 hours with vertical soundings. So people who launch weather balloons, those stations report twice a day. And from that information, we can forecast the weather very well for 3 days into the future and pretty well for a week into the future. Now there's some caveats. There are certain things that are harder to predict than others. For example, snowfall amount is ridiculously difficult to forecast and probably deserves a video in and of itself, maybe once it gets even a little bit colder. But in a nutshell, that's how we predict the weather. And something that I told the kids that you at home can do as well, especially if you're here in the US, is you can be a citizen scientist and set up a weather station at your home and report that data to the National Weather Service. Other things that you can do to support weather forecasting is, let's say there was a big hailstorm that came through your area. You can send in a picture of the hailstone, right, to measure how big it was, to give the National Weather Service more data about that hailfall. Hail, also very difficult to forecast. And as I gave that answer to the kids, that led to the next question, which was, how does hail form? So, hail formation in a nutshell. So here we have a cloud, and then this is the ground, and this line that I've drawn through the cloud is going to be like the freezing point. So up here, it's colder, it's below freezing, and down here, it's above freezing. So when you have a cloud and a storm, especially a storm strong enough to produce significant hail, you're going to have an updraft. An updraft is just wind that's moving up into the cloud. So let's draw our updraft like this. Now let's pretend that this is like a drop of water, right? So this updraft has the ability to push or carry this liquid water up above the freezing point. So it comes up here. Now when it's up here, you'll start to have freezing, right? And so it starts to freeze and then it'll fall down. And if the updraft is strong enough, it'll kick it back up. And every time our starting drop of water goes through this process, it collects more and more water, and then that water freezes. And so the hailstone grows a little bit every time it kind of gets kicked up to the freezing part of the cloud and comes back down. For any meteorology friends watching this, I know this is simplified. I was talking to 5th graders. Love you guys. Okay. And so that's how hail forms. And the stronger the updraft, or even the stronger the storm, the longer the hail will be able to stay in the cloud, right? Until eventually it's just so heavy that gravity pulls it down. But that's sort of why there's a relationship between how strong a storm is and how big of hail you can get. All right, and so our 5th and final question from our 5th graders was, are scientists working to make Pluto a planet again? And the short answer to that is no. And that's because Pluto is actually one of those Kuiper Belt objects that I talked about earlier. So Pluto is a leftover piece from the early solar system that could have been part of a planet, but never did. It never got incorporated. And so now it originally lived past Neptune's orbit in this big, just, I don't know, kind of like cloud of junk. But it's this Kuiper belt, which is, again, all the leftover bits that didn't make it into a planet, and that's what Pluto is. Now, Pluto is interesting because it got pulled out of the Kuiper belt into sort of our regular solar system, most likely by Neptune's gravitational force. And so there were some interesting gravitational interactions. Pluto is really cool as a body, and that's also probably a video in and of itself. But the reason that we're not trying to make Pluto a planet again is because when we learned more about what Pluto is and we learned more about the Kuiper belt, scientists realized that we had incorrectly categorized it before. So we learned something new, right? Turns out we were wrong about Pluto's status as a planet before, and now we can put it in the right category. So I know I certainly have a deep emotional connection to Pluto. I love it. I think this is actually a great example of how science works. We thought something was one way, right? Then we learned more and we were able to better understand it. And so we've recategorized it. So it's not that we don't love Pluto or scientists in general don't love Pluto. We all love Pluto. And now we can better categorize it because we learned more. Okay, team, that's all I've got for you today. Let me know in the comments if you liked this video. I'm planning on doing a few more of these Zoom calls with different elementary school kids. I have a lot of young cousins, and I want them all to love science as much as I do. It's my evil plan. So hopefully we'll have some science questions from different age groups. Honestly, if you've got a kid whose teacher wants to do like a Skype a Scientist kind of thing, shoot me an email, let me know, ScienceSideUp@gmail.com, or write me a message in the comments, whatever have you. I am all about spreading the love of science to all people. That's like my goal in life. I hope you and those you care about are well. Please like and subscribe if you're not subscribed. I'm super close to 300, and I would still really like to break 1,000 subs by the end of the year. So we've only got a few more months to reach that goal, and I'd really appreciate your help. Until next time, bye team.